I spent 4 years trying to make the best Minecraft clone on YouTube, with super cool shaders, and most importantly, fully multiplayer. This is part 2 of the full story of this project, so link in the description if you haven't seen part 1. But now, I will show you how I implemented my entities, the crazy multithreading optimizations I have, and we will also look at the final result. Also, I know you probably also want to make Minecraft in C++ yourself, so subscribe because I will soon release a video with tips and technical details. We left off at implementing entities in the game. I started with something simple, like pigs and cats. Then, I hardcoded their legs animations, so I can see how things go. I managed to invent something that I don't think was ever done before, and I call it compile time entity component system. The way I hold my entities in my game is I have a different container for each entity. So I have an unordered map of zombies, an unordered map of dropped items, and so on. You might think this is weird, but it actually is the most goated implementation ever. Every entity is just a simple struct, and I don't need to use polymorphism. I can also embed the entity type in the ID, so I can search for any entity super fast, and updating entities is also super fast. Again, no polymorphism, so the compiler can go wild with the optimizations. There is only one problem. I need to duplicate a ton of code with this approach. Anytime I add a new entity, I need to add a new container, and then copy-paste code to iterate over it in many places. But what if I wrote code that did this for me? Imagine I wrote some code that could see that I added a new entity struct and update itself everywhere it needs to. This is called metaprogramming, and C++ doesn't really have strong metaprogramming features, but using some questionable macros and also some questionable template code, I created some systems that automatically iterate over all entities. This is weird, but I only need to write this system once, and then, anytime I add a new entity, it will automatically be added everywhere in the code. This will generate a different for loop for each entity, and the compiler will optimize each of them individually. For example, dropped items can't push other entities, so the physics code will skip the container with dropped items completely. Or this training dummy doesn't have any server update code, so the compiler can optimize that away completely. And the result is super nice. I have the shared data that is synchronized and managed automatically by the server, and then I have the server-specific and client-specific implementation of that entity. Then I can add special flags, like this one makes the entity push other entities. In this way, the physics code knows to also check against pigs for entity collisions. And again, all entities that don't have these flags are entirely skipped in that part of physics update. Like, I don't even iterate over those containers in the first place. All I had to do now was to load the entity models and animate them. I use Blockbench to make models, and I load them using async. Then, I implemented a super rudimentary animation system. The animation states are actually managed and synchronized by the server. So the client will receive the entity animation state from the server and update the entity on the client. And even do predictions, like it will always set the following animation if needed, without needing the server. And all I have to do to enable animations is place this flag in the entity, and this will add the animation system to both the client and the server. I even implemented super cool enemy AI. Like, the enemy can hear you, and he actually has to see you before it starts to chase you. But these cool enemy models made me wonder, what if I could also load custom block models? You see, by this point, the game started to take its own identity. I even had some people who wanted to contribute with art, this guy who made the goblin model, and this guy that made some sounds and music for the game. That's why you see this super cool custom sprites for the game. For the gameplay, I decided to make the game just like Terraria, but in 3D. This meant lots of cool custom geometry and custom structures to find. But if you remember last video, when I talked about vertex pooling, I mentioned something about face shapes. Because of how I have my rendering code, I can only render predefined faces, but I realized I can just make the model, export it, then figure out what are the faces for that model when I load the game, and place them in the big GPU buffer with faces, and do that again for every rotation of the model. With that, I can render the custom blocks in game, even with rotations. So in a Terraria-like fashion, this is the Goblin workbench, and I can use it to craft Goblin furniture. And they are also paintable. I made every block paintable, including leaves or even water. With custom geometry, buildings really start coming to life. So I added this structure block that I can use to save custom structures, like this schoolhouse or other structures that would randomly spawn in the world. This might seem simple to implement, but remember, this is a multiplayer game. So this block has to be synchronized with the server, meaning I had to implement the ability to have blocks synchronized with the server. So I did that, and also block entities like this training dummy that I can hit. Using these new systems, I would later be able to implement chests as well, and I'm super happy I have them. Before I talk about the multi-threading optimizations, by far, the number one thing I think Minecraft is missing is cooler procedural dungeons. So the first thing I did was to create some dungeon hallways and some dungeon rooms that can be randomly connected and placed in the world to create a dungeon. They are also made by a block that can be mined in survival, similarly to the Terraria dungeon, so you can't cheat the dungeon like you can do in Minecraft. You really have to fight your way through the dungeon. Speaking about survival, I started to slowly implement it. I made server commands, just for fun, and you can set your game mode to survival. Enemies have to see you to attack you, and you can use a dagger to do a surprise attack on them, adding the possibility of classes to the game. But be careful, they can hear you and turn around. I also added block mining duration, and you can also die. And I also added potions and effects. The development process was quite slow because of the multiplayer aspect, but I would say almost all survival features are at least in a decent state. I also experimented with the world generator a lot. Wouldn't it be cool if each region of the world has a specific difficulty? And some could even have names and custom enemy fortresses inside that you need to fight. So I made a world gen to split the biomes into clear regions that all have a specific height. And also, I know where the center of that region is, to later, potentially, spam the big enemy dungeon there. And what if, once you defeat the enemy dungeon, the area becomes less hostile, and you can make houses for NPCs there, like in Terraria. Speaking of world generator, I improved it a lot. And same for shaders. I made roads that, in the future, will maybe connect points of interest, and rivers that can even carve through mountains, making a super cool boat passage. I added many things that can spawn in the world, and many types of geometry features that can spawn in any biome type. And I made the mountains sometimes be super wacky. I love it. And I added all the basic shader features you might want, like shadows, super cool water, lens flare, god rays, and many small tweaks, making the game look so good. But before we take a look at the final result, let's talk about the two multi-threading optimizations I have. And they basically allow for each client to potentially have its own thread on the server. The first one is computing the chunk geometry on the client on multiple threads. And people view multi-threading very wrong. You don't just want to share your data and use mutexes. You want to instead organize your data so that you don't need any mutex. In this case, I have some workers. Each worker will compute one chunk along with the main thread. And once everyone is done, I can send the data to the GPU from the main thread and continue with my frame. But the multi-threading optimization on the server is even more insane. I realized that if two players are far apart, meaning they have some unloaded chunks between them, they can easily be simulated on different threads with no communication and no mutex between them. And again, people get multi-threading very wrong. Everyone asks me, how do I join and split regions? And if that is expensive? Well, I don't even have to join or split regions. And the secret is in organizing your data right. Every chunk is self-contained, meaning it stores its blocks and entities. If an entity moves to another chunk, it does mean I need to move the ownership of it to the new chunk. Annoying, but not really a big deal. But now, since every chunk is self-contained, the server just has to calculate what the individual regions are, and just send a pointer to those chunks to a worker thread. Those worker threads will just do the updates normally, and also respond to networking events. And once every worker is done, there is super minimal cleanup remaining to do. Before I show you some super cool shots of the final result, I know you probably also want to make a Minecraft clone in C++. So subscribe because I will release a technical video with all tips that you need, and trust me, you don't want to miss it. I have seen the same mistake people do, time and time again. Also, if you haven't made a big game before, you should start with something simpler like Terraria. And if you need help there, you can check out my course. 6 hours of edited video content and 50 plus challenges. I've worked half a year to make this course, so I guarantee you will like it. Link in the description, but it might have a special discount. Now, this is how the project looks now. Right now, I'm quite burned out after working on it for so long, so it will take some more time until I update this project. But this was by far the coolest thing I ever did, especially the multiplayer aspect that I barely touched on this video. If you want to see more of this project, I have an entire playlist linked in the description. Make sure you check those videos. See you there.